by writing f of x equals. You could also write y equals, and then you put your curly bracket. You do one f of x or one y equals. Curly bracket is for the whole equal sign, and that's how you group your piecewise functions. Okay, we have three pieces. I don't know what's the best thing to start with. We could start with the domains of each piece. Like this first piece is this curvy piece here. That's happening when x is less than, and we're going to do or equal to 0, because do you see how that point is filled in there? Versus over here, I have an open circle. Okay, so my next interval is for this linear segment here, and that looks like it's going from a 0 until a 1, 2, 3, 4, 5. Okay, I should have been labeling. So I'm going to go from 0 to 5. Okay, you should ask yourself, do you include 0? No, because of the open circle. Do you include 5? No, because of the open circle. And then finally the last bit, it looks like it's going on forever. So that's happening when x is greater than 5. Okay, should it be greater than or equal to? Ask yourself, well, no, because there's no closed circle there. Now, just for argument's sake, if there had been a closed circle, then you could either put the or equal to sign up in the middle step, or you could put it in the bottom step. However, if you were to put it in both pieces, that is wrong. That makes it no longer a function. Okay, this is a common mistake students make. And it's no longer a function because f is defined in two ways at x equals 5. Okay? So that's a problem. So make sure that if that circle was closed in, that you would have included it in only one of the two spots. Okay? All right. All right, so now we have our domains for this stuff. We need to figure out what the functions are. And once again, I'm just gonna go in order from easy to hard. So this middle line piece here, that's super easy. That's just a horizontal line. I should have labeled my graph. I apologize for being a hypocrite when I nag you guys to label and I haven't, but that's just the equation y equals 2. I don't write y equals because I have this part. This part means y equals. So I just put a 2 there. Y equals 2. It's a horizontal line. The last segment over here is also a linear piece. So that's easy to find the equation of. We need a point and we need a slope. Okay, so I'm going to do slope first. Okay, and I can see, do you guys see how it's down 1 over 2, down 1 over 2? So my slope is -0.5. I can't tell what my y-intercept is, right? Okay, and if I were to track backwards, I may or may not get a nice number. So the easiest thing to do is just identify a point on that line. And we can use a couple different points. We could use the point 5, 2. Now, some of you guys might say to me, well, that point's not actually on the line. Yes, but the open circle is on the line. And so even though the point isn't included, the point is on the line technically. If you don't like that point and you want to use the point, what would it be, 7, 1, be my guest. If you want to use the point 9, 0, be my guest, okay? The reason I like this equation so much is because look in this particular situation, how easy it is to write the equation of my line using that notation. So I don't need the y equals because I have my y equals out front, just like before I said. And I'm gonna do y equals m, so -1/2, times x minus the x coordinate. And I'm just gonna use this one, plus my y coordinate. And I don't have to simplify it. I don't have to do extra work. It's like the best of everything. If you wanted a different version of it, it could be -1/2 times x minus 7 plus 1, or -1/2 times x minus 9 plus 0. Okay, I that was using these other coordinates. If you were to simplify any one of these three equations, you would get the exact same final answer. But the idea is that you don't have to simplify it. So we're choosing a format of the line that's going to save us some work. Okay? All right. And then the last part of this is to figure out that parabola piece. Okay, so for that parabola piece in the beginning, I'm giving away some of my answers. It is a parabola piece. I know in block one, they initially were like, oh, it's a cubic. So one of the things I was saying, well, if it's a cubic, and again, I didn't label my graph the best and I should have labeled it better, but I was indicating that these are 1 unit each. So that's a 4, that's a -2 where it's crossing the x-axis. Okay, so maybe you didn't have enough information, but some of you guys wanted to try a y equals x cubed on this. And if I try a y equals x cubed and I plug in the coordinate -2, I would get a -8, which is definitely not the coordinate I have. If it was a negative x cubed, it'd be a +8. If you look at these numbers, I'm probably dealing with an x squared situation. Okay, so let's rule out the x cubed and let's try an x squared like it's a part of a parabola. All right, now what other clues do we have? Well, it's an upside down parabola. It's definitely a parabola opening down, okay? And that parabola, right, if I were to envision the rest of it, I want it to fall kind of like this, okay? That looks like it's been shifted up 4 units. If that's not clear to you, okay, then you can also say to yourself, okay, well, -x squared, if I do -2 and I do square it, I'm going to get 4 and then multiply by negative, I get -4. What do I have to add to that to get a 0? Or if I were to plug in 0 for x and I square it and then I make it negative, it's still 0. What do I have to add to that to get my proper y-intercept? Okay, my y-intercept is a positive. Sorry, I'm having trouble with this pencil. Is a +4. So I need this to shift up 4. And if you guys want to write it as 4 minus x squared instead, that's fine. -x squared plus 4, also great. Okay, so this is what my function should look like. Okay, my piecewise function right here. Okay, if you have any questions, just send me a message. All right, some of these I'm going to graph kind of quickly. Number 11 is a parabola flipped upside down. Okay, so this is upside down. And then this 5, because it's a +5, it's going to shift me up 5 units. So I'm going to have a parabola opening down, shifted up 5 units. Oh, that line was terrible. All right, better. Up 5 units. There it is. That's all I want from you guys. You don't have to label the x-intercepts. They're not cute. My domain on this, for what it's worth, is all reals. My range is going from everything up until 5, so from -infinity to 5 inclusive. Okay, for number 12, it's -x cubed. The domain of x cubed, I'm not really doing much to this, is all reals. The range is also all reals. That's true for every cubic function. When you have a negative in front of it, it falls instead of rises. So right, it normally is in quadrants 1 and 4. Because of the negative in front, it's going to be in quadrants 2 and I'm sorry, it's normally in 1 and 3. Now it's going to be in 2 and 4. And I'm going to do a half a parabola in that direction and half a parabola in this direction. And I want to make sure that if I were to put something on here, like a cup of, we'll do water this time, like it's going to sit there, okay? So you want to make sure that you have like a little table platform on your cubic functions. For 13, it's my basic cubic, but shifted, well, to ask yourself, where is this equal to 0? It's equal to 0 at x equals 1, so that's where your anchor point is. So it's going to be shifted right 1. Okay, so shift right 1. Okay, draw your half a parabola this way. Okay, and then draw your half of a parabola this way. The y-intercept should always be easy to label. If I plug in 0 for x, I get a -1 for y. And like we said before, for all cubic functions, my domain and my range are all real numbers, okay? All right. For 14, it's sort of an unusually written parabola, but it is a parabola because of the y equals x squared. If you were just to factor it, you'd get x minus 1 quantity squared, which is kind of like 13, except a parabola instead of a cubic. So it's just a parabola shifted right 1 unit, okay? So a parabola shifted right 1 unit. Let me label that a 1. Let me label my x and my y. My y-intercept on this is also 1, and I'm good to go. Okay, my domain on this is all real numbers. My range, I could see on the graph, is 0 and above, so from 0 to infinity. And I'm going to include the 0. Okay. All right. Let's clean up the page a little bit and give us a little bit less clutter to see as we keep going. All right, so now the next, for 15, I have a square root function. Okay, and for my square root function, you want to ask yourself, well, one thing that you guys can do is you could solve for the domain. So I'm going to actually do it up here. Okay, so for my domain, I was mentioning in class that when you guys have a square root function, you need the stuff inside to be greater than or equal to 0. Okay, you need it to be non-negative. If I try to solve this, sometimes that in and of itself will help me figure out what my graph should look like. All right, so if I subtract the 1, I have negative x is greater than or equal to negative 1, and then multiply by a negative, I have an x, a 1, and I got to flip the inequality. So x is less than or equal to 1. Okay, so the reason I'm starting with domain this time, which I normally do not, is that when you have a square root function, a lot of times you guys are not sure which way it should go. Should it go right? Should it go left? Should it be above the axis? Should it be below the axis? Well, the only way it should be below the axis is if I have, like on number 16, I have a negative out front. Okay, that would make it below the axis. The big question here is, do I open right or do I open left? Well, if my domain says that x has to be less than or equal to 1, well, that's, oh, well, I didn't want to go that big. Oh, I didn't want to erase all that either. Okay. Less than or equal to 1 is going to be, fine. Let's call that 1. And less than or equal to 1 is going to be to the left of that. Now, how can I draw that half of a parabola but to the left of this? Let's get another anchoring point. Let's just plug in a 0 for x real quick. If I plug in 0 for x, I get the square root of 1, which is 1. Okay, and then I'm going to draw up and out. Okay. And it's so much easier to do with a pencil than an iPencil on an iPad. Okay, but there it is. Okay, so do you guys see how the domain informs the graph in this case? Because you have the negative in front of the x, it's like flip-flopping the domain. So it's a vertical flip plus a horizontal translation. But I feel like if you just figure out the domain, you don't need to know any of that pre-calc type of language. All right, what else on this one? The range. It's easier to see from the graph, and I could see that I have 0 and all positive y values. So from 0 to infinity would be my range for number 15. Okay, 16 is very similar. And for 16, if you want to do domain again, just like you did, that's super helpful. So set the inside greater than or equal to 0. And if I do that, I get x has to be greater than or equal to negative 2. So for 16, when I go to graph this, okay, I find my negative 2, and I want my domain to be greater than or equal to that. So that's the greater than or equal to the negative 2 part. Okay, and then and when it turns to be like, do I open to the right or to the left? Well, it's pretty obvious that it's going to be to the right now. Okay, if I plug in negative 2, I get a value of 0, and that negative out front, remember we said that it's going to make all our y values negative, so I'm going to drop down and out. Okay, if you want to label a y-intercept on this, you can, but you would just label it as negative radical 2. Remember that negative radical 2 is a perfect answer. It is not an imperfect answer. It's a wonderfully perfect answer. All right. Okay, I'm going to clear some of this, and then we can talk about 49. Okay, as far as 49 goes, this is a formula that you guys really just needed to memorize, or at least to recognize. Okay, just like you recognize when you're driving what a stop sign looks like or what a yield sign looks like, you need to recognize the format of the equation for number 17. And it's the y equals the square root of r squared minus x squared format of a semicircle. Okay, so for number 17, this is specifically a semicircle with radius. Well, the r squared is 49, so what's r? R is 7. Okay, so it's centered at the origin, okay, and it's the positive square root, so I'm just going to draw a semicircle to the best of my ability. Okay, and I'm going to label it to go from -7 to 7, and I can see my domain is from -7 to 7, and my range is from 0 to 7. Okay. All right, the cube root function, I didn't put this on our list of things, but I wanted to see how you guys would do with it, okay? If I think about, oh, I don't know what just happened. Okay, if I think about the domain of the cube root function, can I take the cube roots of positive numbers? Yes. Can I take the cube root of 0? Yes. Can I take the cube root of negative numbers? Also, yes. The cube root of -8 is -2, for example. Excuse me, like I just said, the cube root of -8 is -2, for example, because -2 cubed is -8. So I can take cube roots of negative numbers. So just like our cubic function, our domain is all real numbers. Can I get out positives? Yes. Can I get out negatives? Yes, I just showed you that. Can I get out 0? Yeah, the cube root of 0 is 0. So my range is also all reals, okay? Do you know how the square root function turned our parabola sideways? Well, this is going to turn our cubic function sideways. All right, so our y equals x cubed. Let me just clear this up again. Sorry, guys. So our y equals x cubed looks like this, right? Where when x is positive, y is positive, and when x is negative, y is negative. Well, is that same thing true here? Is when x positive, y positive? Yeah. And when x is negative, does y have to be negative? Yes. So that means I'm dealing with my same quadrants for number 18, that I still have to graph in quadrants 1 and 3. Okay, but much like a square root function is a sideways parabola, this is going to be a sideways cubic function. So instead of being horizontal at the anchor point of the origin, right, I plug in 0, I'm going to get 0, I'm going to be vertical, okay, because it's a sideways cubic function. So I look kind of like a half a parabola that way, and then I'm going to look like a half of a parabola this way. Okay, half a sideways parabola, I should be more specific. Notice that I get very vertical at that anchor point, okay? All right, if you guys have more questions on that, let me know. All right, number 19, home stretch. For number 19, I have my absolute value function, which is my v. How do I know if the v is opening up or down? Well, I look outside the square root, the absolute values, and because outside the absolute values is positive, it's going to be opening up. Where is it centered? Meaning, where is that anchor point? Okay, well, what does the stuff inside, when is that 0? It's 0 at x equals 3, right? So that means when I plug in 3, I'm going to have the point 3, 0. Okay. When I plug in 0, I have the point 0, 3. When else am I going to get out the point? A y coordinate of 3? Well, when x is 6, right? If I plug in 6, I'm going to get a 3. Okay. And then I'm just going to draw my line, and call it a day. Okay. Domain on this, I can put any number into absolute value bars. My range on this, I can see it. My lowest y value is a 0, and my biggest y value, there's no restriction on. All right. Okay, last one, 20, is also a v for the absolute value function. There's still no negative out front, so it's still a v opening up. Okay, as far as when is the inside equal to 0, okay, the inside is equal to 0. If you try to plug in a 2, you'll get -2 minus 2, which is -4. If you plug in -2, you'll get -2, which is +2. minus 2, which is a 0. And the bird is yelling at me. All right, so write negative x minus 2 equals 0 when x equals negative 2. So that's going to be the center of my v. Okay, if you want to double check it, plug in negative 2. If you plug in negative 2, you get negative 2, which is 2, minus 2 is 0. Plug in a y-intercept. Make sure it's looking right? Because the idea is that it's an opening up v, and so it would look like that. So double check. What's the y-intercept? Plug in 0 for x. I get absolute value of 2, absolute value of negative 2, which is 2. Okay, and then see if the reciprocal point would make sense. Okay, when I talk about a reciprocal point, do you guys notice that I went 2 units this way and ended up 2 units up? So try going 2 units this way. What coordinate would be 2 units? What x coordinate would be 2 units that way? Negative 4, right? Plug negative 4 into this. I'm going to get negative 4, which is positive 4. Take away 2 is 2. Absolute value of 2 is 2. My picture is consistent with what makes sense. Okay, so you need to really ask yourself those things. The domain for number 20 is all real numbers. Okay, because there's no restriction on what you could put into an absolute value function. My range on this, I can see because it was staying above the axis. I'm going from 0 to infinity, including the 0. Okay, there is no upper bound on my y values. All right, I hope that's helpful. And if you guys have further questions, let me know.